So chapter 4, practice test. If you really need it, I'd read you something from the first 62, but I would more have in mind to say, like we just did that on the previous video, you could get those all from there. But if you got a stray 1 or 2, I'm on board, but I'm not going to read you 62 of those answers that I just read last time. Does anybody need a stray 1 or 2 confirmed on that first 62? 63 we've done before, so I'll say 63, look for science, composition, and changes as our keywords. Lavoisier, I will make you spell him right to get it right. It's Lavoisier. 65, zeros with bars on them, which should only be in what kind of positions? You don't have to say this on the quiz, but we need to apply this to our lives. Zeros with the bars?
Like thousands.
Only for, I think she said it, whole numbers only. You never put zeros on, or bars on zeros that are in decimal place value positions, only for whole number place value positions. Anything other than 0 is a thing. Zeros at the right end of decimal numbers is a thing. Zeros between other sig figs is a thing. And I wouldn't try to do too much wiggle room on the phrasing of those because you might wiggle into a wrong answer. 69 is rounding first, but based on the place. 71 is rounding last. It's based on the fewest sig figs in the problem. For us, we no longer use those rules. We're just going to pretty much always go 3. But if you end up in a future science setting where they want to use those rules, it's important for you to know those rules exist and people do use them, even though we are not so much going to want to bother with that for the rest of our year. 73 is a K equals. If it's becoming Kelvin, you want the K equals version of that, which is K equals C, and that's plus 273. It can't be the minus in that direction because Kelvin can't go negative, and subtraction is risky on that. It would be fair for me to switch that into Kelvin becoming Celsius. We'll find out tomorrow. 74, look for pure substance, and it can be broken down into something simpler. 75 is a pure substance, can't be broken down. 76 is the smallest part of an element that can exist and still show the properties of that element. 77 is the smallest particle that can undergo chemical changes. 78 is molecules. And then 79 is a mystery as to which half I'll give you. Half of these I'll do name, you do letters. Half of these I'll do letters, you do names. Spelling worth half points as always. You know which 47 will be there, but you don't know which way you're going, whether I say gold and you say AU, or whether I say AU and you say gold, but you do know gold and AU is somehow going to be represented on that. Question up to 125? 77, undergoing chemical changes is the most important phrase. Something about smallest as well should go in there, so something like the smallest particle that can undergo chemical changes, that would work for me. There's ways you could say that too with more words. Questions, anybody, anything up to 125? So 1 point apiece. Test tomorrow is that. Then for the problems will be 4 points apiece. So that'll be a 120-point test day after tomorrow, which is Wednesday on this present calendar week. All the homework would be due by Wednesday from this chapter. Thursday we're back to life and reading and the shortest chapter of the book, I believe. I think chapter 5, if memory serves, only goes to 5:3. Let's see. That's a true story. So 5-1 quiz on Thursday would be your next read. It is a massive 3-point quiz. 5.1. So the quizzes will go 3, then 14, then 31. So not a lot of vocab in this one. 3-point, 5.1 quiz Thursday. Question about schedule and things? So here we go. 1 has 5 protons. How do you know that? It's the atomic number, which is the bottom number. If you know you have 5 protons, you instantly know that you have 5 electrons, because those are supposed to match, at least until we have things starting to gain charges and gain and lose electrons, and that's coming, but that's not come yet to us. And then 6 neutrons, how do you know there's 6 neutrons? Because you subtract 11 minus 5, because that top number is called the mass number, and that's made of both protons and neutrons. 2 has 15 protons, 16 neutrons, 15 electrons. 3 has 22 protons, 24 neutrons, and 22 electrons. 4 has 40 protons, 50 neutrons, and 40 electrons. Does anybody need help on that? Okay, 5 is based on the fact that physical properties are different, while chemical properties are the same. And that it's a matter of which is which. So boiling, is that physical or chemical? Physical, so different. Color, physical, so different. Mass is different because that's physical as well. They have to have different masses. That's what creates isotopes. They have different amounts of neutrons, so they have different masses. So that's definitely different. And then react is a word that means chemical change, so that one is the one that's the same. I don't guarantee you it's those 4 items. Maybe you need a little bit of refresh on what is chemical? How do you know if it's a chemical property?
It produces gas or changes color.
Change of color, gas is formed, basically a reaction would be in that category.
Change the composition.
Yeah, which means a new substance is formed. So burning things, cooking things, reactions, anything where something new comes out, or the color is changed, or gas is produced and you can smell it happening, those are all chemical changes. Those are same. But the physical is the other stuff, cutting and ripping and not rusting, but other things. Those are chemical or physical, so those are different. 9, a thought. The 35, that would get you half of your points. The other half of the points is based on why.
The average is closer to it.
Because 35.46 is closer to 35 than to 37. So why? 35.46 is closer to 35. 10, we're hoping for 58.3 AMUs. 11, we're hoping for 99.1 AMUs. Does anybody need a refresh of how to do that math?
Yes, please.
Okay, so turn percentages into decimals and take each AMU times its decimal and add up the groups. So for 10, we'd go 57 times 0.35 plus 59 times 0.65 and hit it. On 11, make sure you move 2 positions on that 8 and it's a 0.0853. Is that enough?
Yep.
Okay. Anybody else need help to 11? 12 is 2, 13 is 50, 14 is 98. You could do those by running the formula 2n squared, or you could do that by brute force memorization.
Oh, you wanted it to fill the first. Oh, okay. I did it like filling all of them up.
Okay. Yeah, we can't do that because the 7th level can't even be filled.
Okay.
Not with, unless we created some elements like Tony Stark in his basement. It's a little impractical that he built like a particle accelerator in his basement. I digress. I mean, he did live in a big house, but I don't think it's quite big enough to house a particle accelerator
You never know.
to create a new element.
If anybody would have it, it'd be him.
It would be. Up to 14, anything? Okay, so 15, you'd want to draw a nucleus on like the top one, labeled nucleus, but I don't care that you write nucleus, 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 nucleus 4 times, but let's write once on here, nucleus. For 15, we'd have 5 protons in the nucleus, 6 neutrons in the nucleus, And then outside the nucleus, how many can the first energy level for electrons fit? 2. And then the second level must hold, well, in this case, 3, because we want to get to a total of
I didn't know if you meant total. 5.
total of 5. So 2 electrons, 3 electrons. I just drew like my answers look like this: nucleus, level, level. 2 electrons, 3 electrons, 5 protons, 6 neutrons. That's what I'm describing there.
Wait, that's what you want the levels to look like?
That's what I'm looking at.
What would the other three, what would the second level be then?
3, 2, then 3.
No, where would it be on there?
Just
Draw
like-
it out.
The next, like space.
So
Like
just
draw.
keep going into space over and over?
Yeah. So like for 16, we would draw our nucleus. First electron count fills with
2.
2. Second electron fills with
8.
8. So then the next one has the other 5 because we're adding up to 15. Then I'm trying to remember from the diagram where things get wonky. And it has to do with if you're gonna touch level 4 before you fill level 3. So 17, you're gonna have to think about the like flowing diagram thing. As soon as you're above 18, any number above 18, you're gonna have to think about how that diagram works. So for 17, we'd go 22 protons inside, 24 neutrons outside. No questions asked, you can fill this with 2. No questions asked, you can fill this with 8. But then you're gonna have to think about this picture and where it's going. If we're adding up to 20, where in this zigzag flow chart are we ending up? Like, are we in level, like 3S, 3P, 4S, 3D, 4P, 5S? If we run that flow chart until it adds to 22, where are you to get to 22? 3D. Which means you passed through 4S. 4S holds 2. And all of the rest of these are going to be at level 3. Some in the S, some in the P, some in the D, but everybody else is going to be at level 3. But the 4S took 2 to level 4. So how many electrons do we have showing right now? 12. So this has the other 10.
That's ugly.
Anything above 18, you can only answer questions by using that flow chart. Anybody want me to draw the flow chart, explain the flow chart? Okay, so number 18, we're going to go all crazy out of order. So if we're adding up to 40, we have to add our way through that chart up to 40. Where are we? We'd be at 4D. How many are in the 4D? 2. Agreed. Question about how we know that we're up to 4D and the 4D took 2 of these. So how many total levels got touched as we flowed as far as 4D? 5 levels. Level 1, no questions asked, filled with 2. Level 2, no questions asked, filled with 8. Level 5 just barely got touched, only 5S got touched. That got touched with 2. Level 4, did it get filled? Did level 3 get filled? What's going on with those?
I think 3 did before, did I?
3 got filled but 4 didn't. So 3 fills, who gets used to fill 3? 18. Because S, P, and D, all 18 of those got filled there.
And then 10.
And then everybody else is at level 4. So far we're showing, how many are we showing?
30.
30, so we need
10.
another 10 to fill that level. Anything under 18 is easy. Anything above 18, you've got to work through that stop, stop, please don't stop fudge. Question on that group. 19. I will provide you with a tool that will make this possibly easier. What tool could I give you that would make this possibly easier? Periodic table. How does the periodic table tell you how many dots you want? The Roman numerals. So for 19, we want 2 electrons because the bottom number is 2, or because the periodic table puts that in Roman numeral 2. So we're going to write HE, and then we're going to put 2 dots, but this is the one exception where you don't spread them out. You put them as a duo. So which side you put them on doesn't matter, but you're going to go HE and then 2 dots somewhere as a set.
Doesn't it have helium at Roman numeral 8? For helium?
Helium's an exception. Yeah, you're right. It is Roman numeral 8. Helium's an exception to everything, including Roman numerals. You can't trust anything about the periodic table or anything for helium, but helium's number 2. It has 2 dots, so you just do it as a pair. But it also defies the, like, every other element, you spread the dots out, and for helium, you put them as a pair. So helium's one of a kind.
Yes.
20, you don't do 6 dots because of the 6. How many dots do you do? 4. Because the first 2 are at energy level 1 and they don't count. You're only doing dots on the highest energy level. Carbon is in Roman numeral 4, so that does tell you there are 4 dots. So you do the C for carbon symbol, and then we do spread these around. 1 on each side, spread out nice and evenly, and that's our carbon dots. Phosphorus. The easiest way to know how many dots to do for phosphorus is to see that it's in Roman numeral 5 and do 5 dots. So it looks kind of like carbon, but in one of the 5 positions, and it doesn't matter which,
Put 2.
just put a double dot. Cadmium, periodic table, Roman numeral for cadmium is 2, so do 2 dots. Spread them out, don't do them like helium where they're paired. Do it like 1 on each side, and that's 22. If you're not using the Roman numerals, the only way to figure out where you are would be to do the stop, stop, please don't stop fudge thing, and like count them up, and that'd be a real pain. Use the Roman numerals, it's a lot easier. Question on that fruit. Okay, 23, we've got to use the stop, stop, please stop, don't, please stop, don't stop, please fudge. 23 is 1s2, comma, 2s2, and then tell me that there's 2 valence electrons. 24 is 1s2, comma, 2s2, 2p6, comma, 3s2, 3p4, and tell me there's 6 valence electrons. Feel free to use the periodic table to check the valence electrons as a backup plan to your, like, flowing through the chart. The periodic table will not let you down except for helium. 25 is 1s2, 2s2, or 1s2, comma, 2s2, 2p6, comma, 3s2, 3p6, comma, 4s2, comma, 3d10, comma, 4p4, and that has 6. Cadmium is 1s2, comma, 2s2, 2p6, comma, 3s2, 3p6, comma, 4s2, comma, 3d10, comma, Or in other words, repeat the previous answer exactly and now only do differences. 4P6, comma, 5S2, comma, 4D10, and that has 2. And I didn't reach far enough to ever make the 5D cut in line. I don't know if I would do that or not, but if we flowed through as far as 57 or higher, then we would need to get that cutter in line where the 5D would take 1 after the 6S took its 2, and then we resume filling 4F for a little while. Something up to 26. Surprised I didn't do something in the 50s. 27 is 6,260 degrees Fahrenheit. I rounded it there because that was the third position where I hit that 6 and 6260 degrees Fahrenheit. 28 is a question that Aubrey just asked about the other day. Off the general problems, we did some dimensional analysis on this yesterday in school terms, Friday in real day terms because we weren't here on the Sunday. So 28 is 24,600 kilograms on top of meters cubed. That has a set of parentheses that was getting cubed. 29 was another one she asked about. This will have a couple sets of parentheses that are getting cubed. Best answer is 1,530 pounds per cubic foot. 30 nobody asked about, but that was also in those general problems from the last book assignment that was due Friday. It's 2.72
I'm gonna be a problem.
times 10 to the 26 protons.
What was it?
2.72 times 10 to the 26 protons.
And what was 28?
28 was 24,600. And then copy the unit that I had typed,
Yeah.
kilogram per meter cubed.
I'm gonna be a
Problem child?
Yeah, I need you to do 30.
On 30? Okay,
So
so
I set up my dimensional analysis, so I'll know as soon as I did something wrong.
30, what we know we have is a pound. So we start with that. We have 1 pound of stuff. So pounds gotta go. And from pounds in can come grams with 454. Then grams is out and a proton count comes in. And this is telling us that 1 proton has a gram number that I don't feel like writing out on the board because it's scientific notation, but we can see it.
Okay.
So we'll need to basically just do the 454 divided by the scientific notation.
Alright. Yeah, I just set it up completely wrong.
Okay. Yeah, the pounds is what you know.
I didn't realize
So
it
we
was
start
a
from the
pound,
pounds
so
and
I like set it up all funky. I kept the densities. I thought it was all one thing.
Intruder alert!
Sorry, Mr. Costick asked me to give this to her, I think. Chapel, were you doing something for him?
Yeah.
You said yes. Ah.
You said yes.
Yeah?
To doing it.
Was I not supposed to?
No.
Well, it makes you have to do whatever that thing is.
Yeah, I really don't want to. He cornered me at church and I didn't realize I had an option to say no. Did he like ask everybody else before me?
You can always say no. I also said yes, but then I found I have an excuse out now.
What's that?
Mrs. W has to leave early and somebody has to cover the office. So he'll have to recruit another volunteer.
The office.
Yeah,
Yeah,
Nicole covers the
Nicole has to
office.
cover
I'm
the
sure they
office.
would fit you.
She's 18. She could legally. She can
Anybody question on any of this other stuff? I'd be happy to redo 29, 28 if you need that. It caused us trouble yesterday. If it's still trouble, let's do it again. Anything?
Yes.
Yep. What do you, one, both? Both of them. So 28. 28, we'd go to the density up above that has grams per centimeter cubed. The gram number up top is 24.58. And if you really want a number there, just put a 1. But if it doesn't bother you, there's not a number there, you don't need a number there. And then it doesn't matter who you attack first. If you want to kill off grams first, you can. If you want to kill off the centimeters first, you can. Doesn't really matter. But if grams is going to go, where do we need another gram? Bottom. And then anybody in the room, what can we turn grams into? Kilograms is what we want. And what's the numbering there? 1,000 where? On the bottom. So grams out, kilograms in, we're halfway home. The other trade we need to make is from centimeters to meters. So who's going on the top? Centimeters to meters. Number for centimeters. 100 versus 1. But we'd still be wrong if that's all we did. Why is this an imperfect cancel of centimeters? Because it's got to be cubed. So we need to take the whole group and cube, take that whole group and cube. Okay there? Okay. Then the other one is to get to pounds and feet. Can I clear this and just rebuild? So we're faced with similar choices. Grams again needs to go out, and that puts grams on the bottom. This time though, we want to get from grams to pounds, and I have to give you that conversion factor because nobody really knows that 1 pound is 454 grams. That's just not a fact we memorize. Centimeters still wants to go out. Centimeters this time though, we're going to convert to inches, and I'll give you that because not a lot of people know 2.54 centimeters make an inch. And then inches can go out in place of feet. We do know that 12 inches make a foot, so I don't give you that. It's not right, but it's right-ish. You with those jumps? Yeah. Our issue is centimeters cubed needs centimeters to get cubed, which makes this have to get cubed. And now I've got inches cubed, which makes this have to get cubed. And it makes that have to get cubed. And all of those linear measurement groupings, they all have to go parentheses cubes. Is that okay? Anybody want 27? I don't think we talked about 27. You just need to remember your Fahrenheit Celsius formulas. Or if you have a programmable calculator, write a program that does the conversion for you. It would be like 3 lines long. 4 lines long.
So what was the answer?
A display, an input, a math line, and another display for the answer.
What was the answer for
Answer to 29 is 1530 pounds per cubic foot. Anything else I can do anywhere on this? So vocab tomorrow, 125. Problems 4 apiece, that's 120 the next day. And then our very frightening 3-point quiz on 5-1 the day after.